Oh, hello. Here we go. Chapter 4.2. Now, this one you're going to need to read this and become very familiar with these algorithms. These will be used in examples and in the future parts of the class. So, here's some more examples of algorithms. I'll go over them very generally and sort of loosely, but you want to, and it's purposeful, you want to read these algorithms and make sure that you understand them, okay? So the first one is an example of a search algorithm, which does what it says it's going to do. It's going to, so this algorithm searches for the occurrence of a pattern or a word, let's say P, in text T, okay? And it returns the smallest index I such that P occurs in T starting at index I, right? So if P does not occur in T, it returns 0. So the idea is that you input. So what do we input here? P, which is the word, let's say, that we're trying to search for, and the text T, right? Actually P, and then it is indexed from 1 to M, so it's a word of length M, and then we have M, which tells the program what it is. The length of the word. And then we have T, which is the text that it's going to search. And then that is indexed from 1 to N, and then N. And then it's going to output I, which is going to be the index at which P starts, right? And also it's going to return 0, or I or 0. Okay, so here's how it works. Basically, what you do is for I equals 1 to M minus N minus 1. In other words, you search for the word in T, and you only have to do it up until you get to, you don't have to go all the way to N, you just only need to go up to N minus M plus 1, and then J, then it says J equal to 1, okay? And then you go through this here. So make sure you understand that. So what it does is it says, while you get this T sub I plus J minus 1, if it is equal to P sub J, in other words, if everything lines up correctly, then what would happen is that if J turns out to become greater than M, then you just return I because it found the sequence, right? And so look at this loop and make sure you understand how it works, because it goes back to sets J equal to 2 and etc. Essentially, it checks little chunks of the text, and if it finds a word, it pumps out the index I, and if it doesn't, it pumps out 0. So make sure you understand that. Here's a little explanation of how it works. Okay, then we have this idea of sorting. Here's another algorithm that would sort the names, okay? And let's see what we have here. Let's look at the algorithm. Read this in detail, please. Here's insertion sorting. So what does this algorithm do, right? This algorithm sorts the sequence S1 through Sn in non-decreasing order, right? So the input is S and N. The output is S sorted, okay? So look, make sure this makes sense. It'll insert, so for I equals 2 to N, if the value is equal to, it sets value equal to Sj and sort of saves it. And then for J equals I minus 1, what it does is it looks at the value and then it moves over. So value is less than S sub J, right? What it does is it moves Sj right to make room for Si, okay? So while J is greater than or equal to 1 and value is less than S sub J, it sets S sub J plus 1 equal to S sub J. So that's, right, moving it over, and then J equals 1. So look through this algorithm, make sure it makes sense. It should take a while. I'm being purposely vague because you want to really think about this to make sure that you see how it works, okay? So one thing that we're going to be looking at is the time and the space of an algorithm. One thing that's important is to have an idea to measure how long or how effective an algorithm is. So make sure the shortest amount of time it could run would be the best case time. And each algorithm has what's considered a worst case time if everything goes wrong, and that's the longest it would run. So read this over in detail. And then, okay, there's this idea of a randomized algorithm. And we are going to be talking about this and using sort of this idea of a randomized process. Okay, so let's take a look at this idea of shuffling. This is a whole big a randomized algorithm is a huge subject in combinatorics and in computer programming. So, but here's what we mean by this algorithm called shuffle. Okay, so we're going to basically assume that we have such a randomizing algorithm. Okay, but here's a shuffle algorithm. This algorithm shuffles the values in the sequence A1 through AN. So you put in A and the N. So the A is the sequence and N is the length of the sequence. And then the output would be A shuffled, okay? In other words, mixed up, sort of unsorted, right? I mean, so shuffle AN, what it does is for I equals 1 to N minus 1, it swaps AI and this this chooses at random some number between I and N, I believe. But I should probably read the definition. But that's a shuffling algorithm. So you can see there's different types of algorithms that we're going to be studying. And so that sort of wraps up 4.2. Make sure you read section 4.2 in detail so that you get sort of the flavor of how these algorithms work. Okay?